Hi, it's me, Teacher Jeanne. In this lesson, you will learn about factoring polynomials with common monomial factor. After going through this lesson, you are expected to first, identify the common factor of a polynomial. Second, factor polynomial whose terms have a common monomial factor. Now let's define factoring. Factoring is the reverse process of getting the product. To factor a polynomial means to express the algebraic expression as the product of two or more expressions. When a factor is contained in every term of an algebraic expression, it is called common factor. Next, we have the common monomial factor, or CMF. Common monomial factor is a number, variable, or a combination of a number and a variable which can be found in each term of a given polynomial. In this lesson, we need to recall the laws of exponents. First, we have the product rule. Given x raised to m times x raised to n, we have to copy the same base x. Then add the exponent m plus n. For the quotient rule, given x raised to m divided by x raised to n, we copy the base x, then subtract the exponent m minus n. Next, we need to recall also the greatest common factor, or GCF. Given the algebraic expression ax raised to n. So a is the numerical coefficient, which is the largest or highest number that divides evenly into each coefficients of the polynomial. X raised to n is the literal coefficient. So n is the smallest exponent of x in all terms of a polynomial. Now let's have first the example of finding the greatest common factor of 4x squared and 12x cubed. Now let's start with the numerical coefficient 4, and that is 2 times 2. For the literal coefficient x squared, that is x times x. Next, let's have 12x cubed. Let's start with 12. And that is equal to 2 times 2 times 3. For the literal coefficient x cubed, we're going to factor it. We have x times x times x. Next, encircle the numerical common factor 2 times another 2. And for literal coefficients, we have a common factor x times another x. And that is equal to 4x squared. The GCF of 4 and 12 is 4, and the GCF of x squared and x cubed is x squared, which is the smallest exponent of x is 2. Here are the steps of factoring polynomial with common monomial factor. First, determine the numerical common factor and the variable common factor of the polynomial. Second, factor out the greatest common monomial factor of all the terms of the given expression. Third, divide each term of the expression by the greatest common factor, or GCF. Fourth, rewrite the polynomial as a product of the common monomial factor, or CMF, and the remaining factor, or RF. Factor completely. A polynomial is said to be factored completely when it has been written as a product consisting only of prime factors. Any polynomial that cannot be written as the product of two other polynomials except 1 and negative 1 is said to be prime. Now let's have the given binomial consist of two terms, 5x plus 10. Let's start with 5x. 5x can be factored as 5 times x. Next, we have the second term, 10, can be factored as 5 times 2. Then, encircle the common monomial, which is 5. So, that will be your greatest common monomial factor. So we're going to write it in the factored form, given common monomial factor times the remaining factor. So we're going to write the common monomial factor outside, and then we're going to write the remaining factor enclosed using the parentheses. So to get the remaining factor, we're going to divide each term with a common monomial factor. So with 5x divided by 5, we have the remaining x. 10 divided by 5, we have the remaining 2. So the factored form is 5 times the quantity of x plus 2. Easy, right? Now, to check if your answer is correct, we're going to use the distributive property. So using distributive property, we're going to distribute 5 times the first term. So we have 5x. Next, we have 5 times the second term. We have 5 times 2. So 5 times x equals 5x. Then 5 times 2, we have 10. So the product is 5x plus 10. So your answer is correct. Next, given a binomial y squared minus 3y. Let's start with the first term y squared. And y squared can be factored as y times y. Then we have the second term negative 3y. Now as you can see, that minus become the sign of the succeeding or next term. And negative 3y can be factored as y times negative 3. We're going to encircle the common factor y, and that is considered the greatest common monomial factor of y squared and y, because the smallest exponent of y is 1. Next, we need to write it in the factored form, given common monomial factor times the remaining factor. Now, we're going to factor out the common monomial factor y. Means we're going to write y outside the parentheses. And to get the remaining factor, we need to divide each term by y. So we have the first term y squared divided by y. We have the remaining y. And for the second term, negative 3y divided by y, we have the remaining negative 3. Now the factored form is y times the quantity of y minus 3. So those are written as a product consisting only of prime factors. To check if your answer is correct, we are going to use distributive property. We're going to distribute or multiply the common monomial factor y to each term of the polynomial. So we're going to start multiply y times the first term y. Next, we're going to multiply y times the second term negative 3. So y times y equals y squared, negative 3 times y equals negative 3y. So you got it correct. Moving on to the next example, we have y raised to 2m plus 5 minus y raised to 2m. Now let's start with the first term, y raised to 2m plus 5. That is equal to y raised to 2m times y raised to 5. Based on the product rule, as you can see, if we have the same base and we add the exponent, we can expand it by y raised to 2m times y raised to 5. Next, we're going to have the second term, negative y raised to 2m. That is equal to y raised to 2m times negative 1. Now encircle the common, and that is considered your common monomial factor, y raised to 2m. Next, we're going to write it in the factored form, given common monomial factor times the remaining factor. So factor out the common monomial factor y raised to 2m. Then divide each term with the common monomial factor. So we have the first term, y raised to 2m plus 5 divided by y raised to 2m. We have the remaining y raised to 5. Negative y raised to 2m divided by y raised to 2m, we have the remaining negative 1. So the factored form is y raised to 2m times the quantity of y raised to 5 minus 1. Now to check if your factored form is correct, we are going to use distributive property. We're going to multiply your common monomial factor y raised to 2m to each term of the polynomial. So let's start with the first term, y raised to 2m times y raised to 5. Next, let's proceed on the second term, y raised to 2m times negative 1. So y raised to 5 times y raised to 2m. We're going to copy the base y, then add the exponent, 2m plus 5. Next, we have negative 1 times y raised to 2m, that is y raised to 2m. So we get the same product. The next given binomial is 12x to the 5th plus 18x cubed. Now let's start factoring the numerical coefficient 12. So 12 is equal to 2 times 2 times 3. Next, let's have the numerical coefficient of the second term, 18. So we have 2 times 3 times 3. Now we're going to encircle the common factor, which is 2 times 3. We have 6. Now for the literal coefficient or the variable x to the 5th and x cubed, the smallest exponent is 3. So that will be our common monomial factor. Now we're going to write it in the form of common monomial factor times the remaining factor. So we're going to write the common monomial factor outside of the parentheses. Now to get the remaining factor, we're going to divide each term with the common monomial factor. So let's have the first term, 12x raised to 5 divided by 6x cubed. So here, we're going to apply the quotient rule. For the same base, we're going to subtract the exponent. So 12x raised to 5 divided by 6x cubed, we're going to divide first the numerical. 12 divided by 6, we have 2. Then copy the base x, then subtract the exponent 5 minus 3. And that is equal to 2x squared. So that will be your first term on the remaining factor. Next, we have the second term. 18 divided by 6, we have 3. Then x cubed divided by x cubed, we have 1. So 3 minus 3, that is equal to 0. And any number or variable raised to 0 is equal to 1. So we have 3 times 1. And the answer is 3. And that will be your second term. So we have the factored form, 6x cubed times the quantity of 2x squared plus 3. To check if your factored form is correct, use distributive property. We are going to multiply the common monomial factor to each term of the polynomial. So we need to apply the product rule on the literal coefficient with the same base or variable. So we just copy the base and add the exponent. Now first, we're going to distribute the common monomial 6x cubed to the first term, 2x squared. Now multiply first the coefficient, so we have 6 times 2. We get 12. Now for the variable x, we just copy the same base, then add the exponent 3 plus 2. We get x to the 5th. Next, we're going to distribute the common monomial factor 6x cubed to the second term, 3. Multiply the coefficient 6 times 3, we get 18. Then just copy x cubed. So as you can see, we get the same product. So you got it correct. Next given is 15xy cubed minus 5y cubed. So let's have the first term, 15xy cubed. So factor the numerical, 15. We have 5 times 3. Then the literal coefficient, xy cubed, we have x times y cubed. Next, we have negative 5y cubed. Negative 5 can be factored as 5 times negative 1. Then we have times y cubed. Now we're going to encircle the common factor 5 times the common y cubed. Then multiply, we have the common monomial factor 5y cubed. Then we're going to write it in the form common monomial factor times the remaining factor. And the common monomial factor is 5y cubed. Then to get the remaining factor, we're going to divide each term. So let's start with the first term, 15xy cubed divided by 5y cubed. So again, apply the quotient rule for the literal coefficient with the same base. So let's start with the numerical or coefficient. 15 divided by 5, we have 3. We have no common x. Then we're going to have y cubed divided by y cubed equals 1. So we're going to have 3 times x times 1. So that is 3x. first term of the remaining factor. Next, for the second term, we have negative 5y cubed divided by 5y cubed. So negative 5 divided by 5, we have negative 1. Y cubed divided by y cubed, we have 1. So we have negative 1 times 1, the answer is negative 1. That is the second term of your remaining factor. So the factored form is 5y cubed times the quantity of 3x minus 1. Now to check if your answer is correct, we're going to use distributive property. We're going to distribute the common monomial factor 5y cubed to each term of the polynomial. We can apply the product rule. If we have the same base, we copy the base then add the exponent. Now we're going to distribute 5y cubed to the first term. We're going to multiply the coefficient. 5 times 3, we get 15. Then, for the variables x and y cubed, we have no common there. We just copy xy cubed. Then, we're going to have the common monomial factor 5y cubed distribute to the second term, multiply the coefficient. We have positive 5 times negative 1, we get negative 5. Then, we just copy y cubed. So, as you can see, we get the same answer. We got it correct. Next, let's have the given trinomial. 4a squared b to the 5th minus 16 ab cubed plus 20 a to the 4th b squared. Now, let's have first the numerical coefficient. We have 4, negative 16, positive 20. Using the ladder method, we can divide it with the smallest prime number, which is 2. 4 divided by 2, we have 2. Negative 16 divided by 2, we have negative 8. 20 divided by 2, we have 10. Then again, divide it with the smallest prime number, which is 2. 2 divided by 2, we have 1. Negative 8 divided by 2, we have negative 4. 10 divided by 2, we have 5. Now, as you can see, those are relatively prime already. Now, we're going to encircle the common factor, then multiply it. So, we have the common monomial factor, which is 4. Now, let's have the variable a. For the variable a, the least or the smallest exponent is 1. So, therefore, the common monomial factor is a. Now, let's have the variable b. For the variable b, the smallest or the least or the lowest exponent is 2. Therefore, the greatest common factor is b squared. So, we have the common monomial factor for a b squared. We're going to write it in the form of common monomial factor times the remaining factor. So, for the common monomial factor, it's already given. We have 4ab squared. So, to get the remaining factor, we're going to divide each term with the common monomial factor. So, let's have the first term. 4a squared b raised to 5 divided by 4ab squared. So, here we can apply the quotient rule. For the same variable, we are going to subtract the exponent. So, let's have first the numerical coefficient. 4 divided by 4, we have 1. Then, we're going to have 1. For the variable a, we're going to subtract 2 minus 1. For the variable b, we're going to subtract 5 minus 2. And we get ab cubed. So, as you can see, no need to write 1 that is explicitly written or imaginary 1. So, we have the first term on the remaining factor ab cubed. So, let's proceed on the second term. We have negative 16ab cubed divided by 4ab squared. So, negative 16 divided by 4, we have negative 4. A divided by a, we have 1. So, we have negative 4 times 1, and for the variable b, subtract the exponent 3 minus 2. So, we get negative 4b. So, that will be the second term on your remaining factor. Next, let's have the third term. 20a to the fourth b squared divided by 4ab squared. So let's have the coefficient. 20 divided by 4, we have 5. Then b squared divided by b squared equal to 1. So we have 5 times the variable a, subtract the exponent 4 minus 1 times 1. So we have 5a cubed. So that is the third term on your remaining factor. So the factored form is 4ab squared times the quantity of ab cubed minus 4b plus 5a cubed. Now to check if your answer is correct, let's use distributive property. We can apply the product rule. If we have the same base, we just add the exponent. Now let's multiply the common monomial factor for ab squared to the first term. So we have 4ab squared times the quantity of ab cubed. Next, we're going to multiply the numerical coefficient 4 times 1. Then, for the variable a, we just add the exponent 1 plus 1. So as you can see, there is imaginary 1 if there is no number written on the numerical coefficient and the exponent. Now for the variable b, we're going to add the exponent 2 plus 3. So we have 4a squared b raised to 5. Let's distribute the common monomial factor on the second term. So we have positive 4ab squared times the quantity of negative 4b. Multiply first the coefficient 4 times negative 4. Then for the variable a, we have no common there, so just copy. For the variable b, we just add the exponent 2 plus 1. Then 4 times negative 4, we have negative 16, just copy a. Then we have b cubed. Next, distribute the common monomial factor for ab squared to the third term. We have 4ab squared times 5a cubed. Then we're going to multiply the numerical coefficient 4 times 5. For the variable a, we just add the exponent 1 plus 3. Then just copy b squared. Then 4 times 5, we have 20. A raised to 4, we have b squared. So as you can see, we get the same product. We got it correct. Let's do more. Factor completely. Now we have the given table. For the first column, we have the given polynomials. Second column, we have the common monomial factor. Third, we have the remaining factor. Fourth column is the factored form given the common monomial factor times the remaining factor. Now first one, we have 2x plus 10. So we're going to factor out the common with the coefficient 2 and 10, which is positive 2. Now to get the remaining factor, we're going to divide each term. So 2x divided by 2, we have x. 10 divided by 2, we have positive 5. So we have the remaining x plus 5. Now to write the factored form, we just simply have 2 times the quantity of x plus 5. Now second, we have negative 18m minus 12. So the common with negative 8 and negative 12 is negative 4. Now we have no common on variable m. That is not given on the second term. So therefore, we just have the common monomial on the coefficient only. Now to get the remaining factor, we just divide each term with the common monomial factor. So negative 8m divided by negative 4, we have positive 2m. Negative 12 divided by negative 4, we have positive 3. So we have the remaining factor 2m plus 3. So the factored form will be negative 4 times the quantity of 2m plus 3. Next, we have the trinomial 3x cubed minus 12x squared minus 9x. Let's start with the coefficient. We have 3, negative 12, and negative 9. And the common is, we have 3. Then for the variable x, the least or the lowest exponent is x raised to 1. No need to write 1. That is imaginary. Now, for the remaining factor, we're going to divide each term with the common monomial factor. So 3x cubed divided by 3x. So 3 is cancelled, that is equal to 1. Then copy the base x, subtract the exponent, 3 minus 1, we have 2. So we have negative 12x squared divided by 3x. So negative 12 divided by 3, we have negative 4. Then x squared divided by x, we have x. Negative 9x divided by 3x, we have negative 3. Cancelled x divided by x, that is equal to 1. So for the factored form, we just multiply the common monomial factor 3x times the quantity of x squared minus 4x minus 3. For the last, y raised to 5 plus y cubed. So as you can see, we have no coefficient there to factor. So let's have the variable y. And the smallest or lowest exponent is 3. So we have y cubed. So for the remaining factor, we can apply the quotient rule. We just subtract the exponent. So y raised to 5 divided by y cubed, we have y squared. And y cubed divided by y cubed, we have positive 1. So for the factored form, we can write y cubed times the quantity of y squared plus 1. Now it's your turn. Do it yourself. Let's see if you learned something on this video. Factor the following polynomials. Number 1, 27a plus 9. Number 2, 3x squared minus 12xy. Number 3, negative 5m squared n plus 25mn squared. Number 4, 7n cubed minus 35n squared minus 28n to the fourth. Number 5, x to the n plus 3 minus x to the n plus 4 plus x to the n plus 5. Don't forget to comment down below your answer. Happy learning! Thanks for watching! Please like and share. And don't forget to subscribe on my channel and click the bell button so that you will be notified whenever I'm going to upload a new one. Maraming salamat!